All right, let's dive into this wild hypothetical scenario. A simple what if that really peels back the curtain on how our world actually works. And believe it or not, it all kicks off with a tiny, almost unnoticeable change. Okay, I want you to picture this. We're in the city of Bern, Switzerland. The year is 1905. You've got bustling streets, and the world is right on the edge of this massive scientific revolution, but nobody really knows it yet. And high above the city, the main clock tower, the symbol of order, of precision, is running just 2 minutes behind schedule. It's a tiny little error. In the grand scheme of things, it's nothing, right? Or is it? So, because of that 2 minute delay, a man who relies on that clock to wake up, well, he doesn't. He's late. He rushes around, gets a bit flustered, and ends up leaving his house a full 5 minutes later than he normally would. Now, at this exact same time, there's another man, a banker, driving his shiny new car. He's feeling on top of the world, but what he doesn't know is that there's a critical and very dangerous flaw in his car's braking system. So, as our guy who's running late hurries to cross the street, that car with the bad brakes is coming. Their paths intersect at a single moment in time, a moment they were never supposed to share. The car can't stop, and the man who is struck and killed is a young Albert Einstein. And in that one tragic instant, history is completely rewritten. See, that very year, Einstein was about to publish the papers that would become the foundation of modern physics. Without him, the theory of relativity, it's never born. That means no GPS, no television screens, no semiconductors. All the technology that powers our world today, from our laptops to our phones, it all just vanishes. The world as we know it simply ceases to exist. Now, this crazy chain reaction, all stemming from a 2 minute delay, it completely shatters the view of the universe that had dominated science for centuries. For the longest time, we saw the world through the eyes of Isaac Newton, as a place that was orderly, and most importantly, predictable. This idea has a name. It's called determinism, and it basically imagines the universe as this giant, intricate clock. The thinking was, if you could just know the exact position and speed of every single gear at one moment, you could predict its entire future with perfect accuracy. But as our little story shows, reality, it's a whole lot messier than that. So how did we figure this out? Well, let's fast forward to 1961 and see how this whole new understanding came about. And it wasn't from some grand theory, but from a simple mistake made by a meteorologist named Edward Lorenz. Lorenz was using one of those early room-sized computers to try and predict the weather. One day, he wanted to take a closer look at a weather pattern he'd already simulated. So, to save a little time, instead of starting the whole thing over, he just typed in the numbers from the middle of his last printout and hit go. Then he walked off to get a cup of coffee. When he came back, he saw something that just should not have been possible. The reason for this huge, dramatic change was almost nothing. It was so small. See, the computer was working with numbers out to 6 decimal places, but the printout, just to save space, only showed 3. So Lorenz had typed in 0.506 instead of the full 0.506127. The difference was, infinitesimal. He later tried to describe how small this change was, saying it was like a single particle of dust on the Eiffel Tower or one less feather on a duck. For all practical purposes, it was nothing. And yet, this nothing completely and totally changed the future of his weather simulation. This whole experience led Lorenz to a really profound and now famous conclusion, which he presented with a wonderfully poetic title. He realized that in really complex systems, like our weather, a tiny, almost unmeasurable change at the start could lead to enormous, wildly unpredictable consequences down the road. This is the butterfly effect. Okay, so this is absolutely the key idea. This extreme sensitivity to the starting conditions, that is the heart and soul of chaos theory. But it's so important to understand what the word chaos actually means here, because it's probably not what you're thinking. Yeah, this really gets to the heart of the biggest misconception. Chaos is not the same thing as just randomness or disorder. In a chaotic system, every effect still has a cause. It's all following strict mathematical rules. The problem is, the system is so incredibly complex and sensitive that trying to predict what it'll do long-term becomes impossible. And yet, hidden inside all that unpredictability, you often find these beautiful, intricate patterns. Now, this isn't just some abstract idea for mathematicians to chew on. Understanding these chaotic systems actually has incredibly practical uses that affect us every single day. So you might be asking, why does this matter to me? Well, we see it everywhere. Take finance, for example. It's why experts talk about probabilities, not certainties, because one tiny event can trigger a huge market crash. In medicine, it helps doctors make sense of the irregular, unpredictable rhythms of a heart with arrhythmia. And think about our social world. It's how one single nasty comment online can spiral into this massive, unpredictable wave of trolling. So, what is the big takeaway from all of this? What does chaos theory ultimately teach us about the universe and, our place in it? First, and this is really important, chaos does not mean the universe is broken. The fundamental laws of cause and effect are still in charge. Gravity still works, planes will still fly, and I promise the sun will rise tomorrow morning. But it does introduce a profound sense of humility into how we see the world. And that's really the final, most crucial idea. Chaos theory shows us the fundamental limits of what we can ever know. Even if we had the perfect laws of physics, we can never measure the starting position of everything with perfect accuracy, right? We can't track every single butterfly's flap. And because of that, some things in our universe will forever remain beautifully and maybe even wonderfully unpredictable.